This is the excess charge on ordinary objects lab, and the problem we had to solve in this lab is we need to determine the excess charge on a piece of tape based on simple measurements of mass, distance, and length. We can do this with a fairly simple experimental setup, as will be discussed in the next few slides. And the results overall of this experiment showed that the magnitude of the charge on the tape fell within a factor of 10 to the negative 8, which is reasonable considering the range could theoretically be between 10 to the negative 19 and to the 5th. We will go through the experimental model, results from the experiment, calculations, the coding, and some theoretical questions. So the model in this experiment had 3 parts, the first being to determine if the tape is positively or negatively charged, the second being to float 2 like-charged tapes, one above the other, and the third being to consider the 2 tapes to be like point charges in glow script so that we could model it. And we used the principle of momentum in this experiment. As you can see here, we knew that momentum was equal to 0 during the floating tapes part. And since we know that, it boils down to electric force being equal to gravitational force. And the assumptions that we used in this experiment include ignoring air resistance, treating tape as a point charge, and assuming that each tape has the same charge evenly distributed. So this experiment, as I said, the first part is determining the sign of the charged tapes. So we charged the tapes and the tails of 2 of them repelled away from each other, and we saw a slight attraction to neutral objects, and it's hard to find something truly neutral. And the tape was strongly attracted to negatively charged plastic pen. And this tells me that the U tapes are/were positively charged. And then the floating tapes part, we know that gravitational force equals electric force since momentum is not changing as previously shown. And since we know the gravity constant, we just need to measure the mass of the tape, which will give us gravitational force, which will ultimately give us electric force. So in my experiment, the length of my tape was about 0.2 meters, the mass was about 0.0002 kilograms, and the distance between the floating tapes was 0.02 meters. Here I calculated the gravitational force, which is just m times g, the gravity constant times the mass of tape, and it came out to be negative 1.98 times 10 to the negative 3 newtons. And since we know that electric force is equal to gravitational force, we know that electric force would just be the same but opposite charge of the gravity force, and that is positive 1.98 times 10 to the negative 3 newtons. So the calculations I did in this lab, first I calculated the charge of the tape. As you can see here, it came out to be about 1.03 times 10 to the negative 8 coulombs. And then the deficiency of electrons on the tape, since it was positively charged, we know that there is a deficiency of electrons, and that came out to be about negative 6.45 times 10 to the 10. And then the ratio of molecules that gave up electrons comes out to be about 32 atoms per 1 electron, which again makes sense because the tape was positively charged. Right, so the coding in this lab, as you can see here, we first create 2 point charges to represent the 2 floating tapes, and then 2 arrows representing the gravitational and electric force. And as you'll see when I run the code, they're the same size but opposite directions. And then from lab 0, I was able to use the E-field function to calculate the magnitude of the electric field on the particles. And then down here I have calculated the charge of the tape, the number of electrons on the tape, and the electric fields. So I'll go ahead and run that. And as you can see, we have 2 point charges here representing the bottom and top tape. And then the green arrow represents the force of gravity, while yellow represents the electric force. And they are the same size, but opposite directions. Once again, going back to that principle of momentum being equal to 0. And then the theoretical questions for this lab. So if electrons had positive charge and protons had negative charge, it would change the direction of the electric fields of each of them, and observations from this experiment would have changed, like the tapes would have been negatively charged and the signs of calculations would be flipped. And it is important not to handle tapes too much because they lose their charge when there is a transfer of electrons through contact. And in conclusion, charges can be small but very significant. As you saw, we were able to calculate a lot of things from a few simple measurements from pretty small charges. And when momentum is zero, gravitational force equals electric force, which was the overall arching physical principle that governed this lab. And then also basic experimental techniques can give us insight into pretty powerful physical principles.